You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back. You know, it feels like every time the calendar flips to a new year, the tech world just decides to hit us with an avalanche.
It's more than an avalanche. It's a flood. New chips, new software, new robots.
All at once. It's an immense amount of information to sort through.
It is.
Yeah.
And it's not just product launches. It's a real fundamental shift happening. So our goal here is to, filter through that for you. We want to skip the hype.
Right.
And focus only on the changes that really matter. The things that change how we build, how we buy, and how we live with all this technology.
Exactly. So we're going to look at three massive movements that are all kind of interlocking. First, we have to talk about jobs, right?
Yeah.
How AI is completely redefining what it even means to be an engineer.
The whole concept of coding is changing.
Then we'll get into the hardware. Almost unbelievable computational power that's coming out of these labs.
Extreme hardware.
And finally, we'll see how that power is showing up in the physical world.
I was surprised at how fast things are moving with robotics and autonomous cars. It's a revolution on multiple fronts.
Yeah.
So let's just jump in. Let's start with where the impact is most immediate, the software development pipeline.
Okay, so the biggest story here, it seems to me, isn't just that an AI can write a piece of code.
No, not at all.
It's that the AI is compressing the entire process of building software. And the best place to see this happening is with the product manager role.
That's the perfect vantage point.
Yeah.
I mean, for decades, the job of the PM was to be that translation layer.
Right. They'd take what a customer wanted, which was always vague.
Always vague, yeah. And they translated it into these super detailed technical specs for the engineers. The PM was basically the architect of the intent.
And now?
Yeah. The barrier to implementation has just dropped off a cliff. So PMs are just skipping the human engineers.
They're writing specs for the AI.
Directly for AI agents to implement. It's a massive leap in efficiency. And it means the bottleneck, the hard part, moves completely.
So it's not about coding speed anymore.
Nope. The scarce resource is having the clarity to know what's actually worth building in the first place.
So if the AI is handling the code, that has to be hitting developers hard. We keep hearing this term, the disappearing middle of software work.
We are. And it's real. These agents are getting incredibly good at taking a goal, build me a microservice that does X, Y, and Z, and just spitting out code that works.
So all that grunt work in the middle is just gone.
It's shrinking fast. The craft is shifting. It's less about writing the code and more about directing and managing the work of these agents. It's a conceptual job now.
That makes a lot of sense. So if the AI is writing code that fast, how do you make sure it's any good, that it's reliable? I heard something really interesting about the kinds of programming languages people are choosing now.
Oh, yeah. The move toward typed languages.
Like Rust and TypeScript. Why is that?
It all comes down to trust and evidence. If an agent writes 10,000 lines of code for you in a minute, you need some way to prove it works.
Without reading every line.
Exactly. Static types, they enforce rules on the code so the compiler can catch the AI's mistakes before it even runs. It's like a built-in quality check. It just makes the AI's output more trustworthy.
So the job becomes less about velocity and more about oversight and proof. But to manage these agents, you must need some kind of scaffolding, right? To stop them from just running wild.
You do. You need what's called an agent harness.
An agent harness? What's that?
Think of it like a project manager for the AI. It's a system that wraps around the AI model to manage what it's doing, especially for these long, complex tasks.
So it's about accountability.
Precisely. It turns a vague instruction like update the dashboard into structured, loggable data. You can see every step. That's vital because it lets you debug and improve the system with real feedback. Without the harness, the AI is just a chaotic black box.
Okay, that's the technical side. But let's talk about the chilling commercial reality of this, the case of Tailwind.
Yeah, this is a big one.
From what I've seen, their project is bigger and growing faster than ever, but their revenue is down almost 80%. How does that even happen?
It's a direct result of this agent revolution. Tailwind sold commercial products, and developers found those products by reading their documentation.
Okay.
But traffic to that documentation is down about 40%. Why? Because the AI agent just gives the developer the answer directly. They never have to visit the website.
So they bypass the storefront completely. And the human costs?
75% of their engineering team lost their jobs. This is the canary in the coal mine. It shows that user productivity gains don't always mean revenue for the company that created the knowledge in the first place.
Okay.
So that's the displacement we're seeing in software. It's happening fast. But none of that AI coding is possible without this relentless geometric growth in raw computing power.
Right. So let's shift from the agents themselves to the extreme hardware that's making it all possible.
And this is where the numbers get kind of mind-bending.
Let's start with quantum computing. Google's Quantum AI Lab has this thing called the Willow chip. And it sounds like this chip has finally settled the debate about whether quantum computers can actually do things normal computers can.
It has settled it, definitively. It solved a benchmark problem in just a few minutes.
And a normal computer?
The best classical computer in the world would have taken 10 septillion years.
10 septillion years.
Yeah.
I have to stop you. That's a number that is so big it's meaningless. What is the one practical thing that unlocks today?
The practical application today is the proof itself. It settles the argument. Quantum supremacy is real. This isn't just physics theory anymore. It's an engineering problem now.
So the money follows.
Exactly. It accelerates investment. It accelerates research. Pharmaceutical companies, cryptographers, they all have to take it seriously now. The capability is confirmed.
Okay, so beyond quantum, the more. Conventional battle for GPUs is heating up. Nvidia is still on top, obviously, and they're about to ship their Vera Rubin AI chip.
Right, the Vera Rubin is all about AI inference. That's fulfilling all those millions of queries we make every day, but faster and cheaper. It's all about optimizing the cost per query.
But they're getting some serious competition, especially on the power consumption front.
They are. Electricity is the new bottleneck. You've got startups like Furiosa coming out with these new neural processing units, or NPUs.
And their edge isn't just speed.
It's energy efficiency. Their NPUs give you similar performance to top-end GPUs, but use way less electricity. And if you're building a massive data center, your power bill it's astronomical.
Yeah.
So that efficiency is the new battleground.
And this push for power and connectivity isn't just happening on the ground. We have former Google CEO Eric Schmidt funding the Lazuli space-based telescope.
Right, which is designed to be a more capable replacement for Hubble. It just shows that space-based infrastructure is becoming critical.
And Amazon is right there with them, connecting their cloud to space. Amazon Leo, which used to be Project Kuiper.
They're launching very soon. And they have a really clear three-tier strategy. Their top-tier service, Leo Ultra, offers speeds up to 1 gigabit per second.
But that's not for you and me.
No, it's for enterprise customers. And what this signals is that they're planning to support the traditional broadband providers, not bypass them. They want to expand the global network, not just compete with your local ISP.
Okay, so let's pull all of this back down to Earth. Away from the data centers and satellites and into the physical applications we're finally starting to see.
This is where AI moves out of the cloud and into our world, starting with the robotics and the humanoid race.
And this race is getting intense. You have Elon Musk basically betting the future of Tesla on the third generation of Optimus.
And his goal is, well, it's staggering. He talks about generating infinite revenue and eliminating poverty.
Very lofty goals, but we're also seeing very concrete industrial steps with Boston Dynamics Atlas. This isn't just a viral video anymore.
That's the key. Atlas is entering production. The first ones are going to Hyundai and Google DeepMind. This is industrial reality.
And what can it do?
The final version has a reach of 7.5 feet, and it can lift up to 110 pounds. But what's critical is the flexible control. It can work on its own, a person can operate it remotely, or you can just use a tablet. It's built for the factory floor.
We're seeing similar progress in self-driving, but with some creative legal workarounds. Waymo is updating its fleet with the Waymo Ojai van.
Right, which is built by the Chinese automaker Zeekr. But here's the clever part. Zeekr builds the body in China. Just the rolling chassis, basically.
And then they ship it to the U.S.
Exactly. Then Waymo installs all its software, all its sensors, all the high-level autonomous gear here in the States.
So why do it that way?
It's a brilliant way to sidestep U.S. regulations against selling Chinese cars directly to consumers here. Innovation always moves faster than the law.
And finally, let's talk about the most personal integration. Health. OpenAI is testing ChatGPT Health.
This is a very sensitive one. It lets you connect your medical records and wellness apps to ChatGPT.
To make the answers more personalized.
Right, grounding its responses in your data. But they're drawing a very, very hard line here.
What's the line?
They've been crystal clear. It is not for diagnosis or treatment. Think of it as a tool to help you understand your own data or what your doctor told you. It's a navigation aid, not a replacement for a medical professional.
So with all of this happening so fast, the race for market dominance is it's heating up like never before. Here on Vocal Technologist, we're always trying to track where the power is shifting.
And that picture has changed a lot recently. For a while, everyone thought Google was lagging way behind OpenAI.
They were.
But they've had this incredible recovery. By September, their Gemini AI app was the most downloaded app on Apple's App Store.
That's huge. That means they are winning the consumer race for reach, at least for now. Meanwhile, XAI is just raising an incredible amount of money.
A monumental amount. A $20 billion Series E round. That's a war chest aimed squarely at building out compute infrastructure. And they're already rolling out business products, like Grok Business.
So they're building the foundation to compete long term.
Exactly. Now, OpenAI, they're trying to build their own app store, trying to let you do things like order groceries right from the chat. But is it working?
It sounds clunky.
It is. Early reports say it takes too many extra steps, it lacks basic functions, and it just sends people back to the normal apps they were using before. The idea is powerful, but the execution isn't there yet.
And then there's Amazon still trying to get into this top tier with Alexa plus Forna.
Yeah, and it's in free early access right now, which is good because apparently it's slower than expected and struggles with being accurate.
Not a great start.
Not at all. They plan to eventually roll it into Prime or charge $20 a month, but they have to fix those fundamental problems first.
All right, let's wrap up with a few absolutely wild consumer predictions that are coming out of this whole environment.
Yeah.
First, the idea that our phones are actually too powerful and that all these dedicated screenless AI devices are going to flop. Same for always listening gadgets.
I like that one. Good pushback against the hype. There's also the prediction that by 2030, the cost will be so high that we'll only have 2 big general-purpose AI chatbots left standing.
And the real kicker, the one that tells you everything about where consumer attention is going, the prediction that the fastest product ever to reach $1 billion in recurring revenue
Oh, I know this one.
will be an AI webcam girl.
Wild. So if you zoom out and try to connect all of this, what you see is the barrier to implementation just dropping everywhere, whether it's writing code or simulating new materials with the Willow chip or building a robot like Atlas.
The technical how is getting easier.
It's getting so much easier. But that just raises the importance of the conceptual what. Knowing what to build becomes the critical skill.
Absolutely. I mean, from the job cuts at Tailwind to the Willow chip settling a decades-long debate to Optimus already being in its 3rd generation, the rate of change is just astronomical. This idea of continuous learning isn't just, good career advice anymore. It's survival.
It is. And that leads to a final provocative thought for you to take away from all this. This big shift we've talked about, moving from being a code writer to becoming a system orchestrator.
Yeah.
Some people are calling it compound engineering.
Okay.
So if the AI agents are going to handle all those steps in the middle, the question for you becomes, what systems, what constraints will you need to build around them to make sure they are reliably useful for the goals that really matter? You have to think less about writing the code and more about designing the container it operates in.
Spoken Tech for your ears.